All right, Algebra 1A students. Welcome to part 1 of your video on lesson 4.1. We're starting a new chapter in this video. Today's video is about using graphs, pictures basically, to relate two different quantities that are changing in relation to each other. So we're going to use graphs to visually, meaning in pictures, represent the relationship between two quantities that are changing. Okay? And the first thing that you're going to be asked to do is analyze a graph that you're given of a certain situation. Okay? So here we're told that the graph shows the volume of air in a balloon as you blow it up until it pops. What are the variables? Describe how the variables are related to each other at various points on the graph. Well, the nice thing is that first part of the question, what are the variables, is answered very easily from this graph picture over here. The variables are always the labels on the two axes. Okay? The variables are always the labels on the two axes. So in this case, your two variables are time and volume of air. Time and volume. So we would say the variables are volume and time. Okay? That's the easy part of this. And then they just want, we need to be able to analyze what's happening in this graph. We have to see this graph and sort of picture what's going on here in real life. Well, we have this balloon that we're continually blowing air into, and it starts down here right when we begin at time 0 with no air in it, right? 0 volume of air. And then there's kind of this upward little stretch of air going into the balloon, and then it levels off for a second. And then more air goes in, and then it levels off for a second. And then more air goes in, and then it levels off for a second. So what we should realize is that each of these times that it levels off, we're taking a breath, right? The volume goes up as we blow air in, and then it stays where it is while we take a breath in through our nose and then continue blowing air in. Okay, so that's kind of what they're saying here. The volume increases each time we blow, stays consistent each time we pause to breathe. Okay, and then here, after 1, 2, 3 breaths, we blow in and too much air, and this is the moment right here where it all goes wrong. It pops, goes kaboom, and obviously the volume of air instantly drops down to nothing. So that point is where it pops. Right? When the balloon pops in the middle of the 4th blow, after 3 breaths, the volume decreases to 0 instantly. Okay, so all we're doing here is we're saying what the two variables are, and we're analyzing the real life situation that we're seeing here in the graph. Okay, so we'll do one more together, then I'll have you do one yourselves. Okay, let's do letter B together, and then I think you can do letter A pretty easily. So in letter B, again, we're going to tell them what the variables are in this graph or in this situation. The variables here are minutes of phone calls and the cost of my cell phone bill. Okay, the variables are minutes of phone calls and the cost of my cell phone bill. And what we see happening is the cost is constant until we reach some kind of limit, right, on our minutes of phone calls. Then the cost increases as we use more minutes. I'm not sure if you guys know, this is how cell phone bills used to work. You used to get a certain number of minutes that you could be on the phone for free or for no additional cost, and then once you hit that limit of minutes on the phone, your cost would start to go up because you were on the phone for longer and longer and longer. Okay? So that's just describing what's happening there in that real life situation. The cost of my cell phone bill stays constant until I hit some certain limit of minutes, and then it rises as I use more minutes. Okay? I'd like you to try that with this graph over here. We have a graph of board length. It's some kind of board, some kind of piece of wood, and the length is changing over time. So see what you can do with that one. Tell me the variables, and then write me maybe a sentence of what's happening with that graph. Okay, the variables here are time and length of the board. And what we see happening is the board is being cut shorter at different intervals of time. Because as we can see, time starts out with the board length being here, and then right here, boom, it drops down, the length drops. It was cut right there. And then we reset, a little more time goes by, and boom, we cut it again. A little more time goes by, boom, we cut it again. We did 3 cuts. 3 cuts total are made in this board. Okay, so I'm telling them what the variables are, what the 2 labels on my axes are, and then I'm sort of describing what I see happening in this graph. Okay, so hopefully that's something you feel like you can do on your own. The other thing that we have to be able to do with graphs in this video is to understand how a graph is related to a table of numbers or a table of values. Okay, so here we have a band that's allowing fans to download its new video from the website. And the table shows, this table over here shows the total number of downloads after 1, 2, 3, and 4 days of that video being released. Which graph could represent the data shown in the table? Well, what we have to do is look at these numbers and see how they're related. Now, obviously, day 1, 2, 3, and 4 are just going up, like this 1, 2, 3, and 4 in all of these graphs. So that's not really what we're worried about. What we need to look at is how high up on the total downloads axis each of these red dots are in these 4 options that we could choose. Okay, because obviously at day 1 we have 346 total downloads. Then at day 2 we jump up to be 1,011. Then we jump up to 3,455. Then we jump up to 10,426. So what we have to do is kind of analyze what's happening with those numbers of downloads so we can see how high should these red dots be in my graph. Well, the first one I think we can eliminate is letter D right down here. I know for sure it is not that graph because that one starts out really, really high, and as the days go, I actually get less and less downloads, but here we clearly see that we're getting more and more downloads as we go the 4 days. So letter D cannot possibly be correct. Okay. Letter A, it appears that these dots are right in a straight line, and what that would mean is that each of the days going by, we get kind of the same increase in total downloads. So it's going up by the same number every day. But that's not true because here in total downloads on day 1, we have 346. We jump up to 1,011, and that is an increase of like almost 700. Approximately 700. But then the next day, look at this jump. We go from 1,000 over to 3,000. So that's like 2,000 downloads that we gained on that day 3. So obviously these are not increasing by the same amount because the next day we get basically 7,000 then on day 4. So we're increasing actually by more and more each time. So it's definitely not letter A. Right? It can't be letter A because it's not going up by the same amount. And now we have to choose between B and C. Well, B shows it pretty low on day 1, and then it gets higher on day 2, and then it gets even higher than that on day 3, and then it gets really high on day 4. And letter C shows us that we're kind of in the middle on day 1. We go up quite a bit on day 2, go up a little bit less on day 3, and then by day 4 we're kind of like flattening out, not going up by much at all. So obviously the better choice here is letter B because what we see in this table is that these numbers of downloads are going up by more and more and more, which means we should see these dots, these red dots, jumping up higher and higher and higher on our graph as we go. So the correct answer here is letter B because that's the one that shows these downloads increasing by more and more and more each day that goes by. Okay? I'd like you to kind of use that same logic and take a look here at these number of uses and the amount of sunscreen left in your tube, or in your can, I suppose, based on the number of times the sunscreen has been used. Okay, number of uses 0, 1, 2, 3. So obviously 0 and then 1, 2, 3. 0, 1, 2, 3. 0, 1, 2, 3. Okay, so pick A, B, or C to go with this table, and then make sure that you could understand or explain why, and not just take a random guess. Okay, take a couple seconds to look at that, then come on back and I'll show you what we should have. Okay, the correct answer here is C. It's not B, because what we should notice is that the amount of sunscreen continues to go down by the same amount. It drops by 0.2 there, drops by 0.2 there, and it drops by 0.2 there. And this is going down all of a sudden very steeply, like dropping off, like we're using so much sunscreen that third time for no apparent reason. So it's not letter B. Letter A, the issue we have here is that look what happens when we get to 3 uses, 0, 1, 2, 3. At 3 uses, where are we on our amount of sunscreen axis? Well, we're already down at 0. Right? It's like we have no sunscreen left at all after 3 uses, but that's not true. We have 4.4 ounces left. So letter A is wrong because it drops far too fast and gets down to 0 when we know there's still 4.4, which leaves letter C a steady, kind of casual drop off. All right? So hopefully we're starting to understand what these graphs can show us, even when they're just rough sketches. They can show us variables. They can show us kind of what's happening in a real world kind of context or situation. If you have questions about these graphs at all, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.